Betelgeuse, a red supergiant star, is one of the most captivating objects in our cosmos. If it were positioned where our Sun resides, its colossal size would extend out to the orbit of Jupiter. This immense star is highly unstable and on the verge of detonating, making it one of the most significant sources of radio energy in the universe. Betelgeuse produces more energy than 1 billion suns. Its enormous scale and instability have fascinated astronomers for centuries. Located in the constellation Orion, Betelgeuse has exhibited unusual behavior in recent years, including significant dimming and violent oscillations, which have prompted speculations that it may soon explode in a supernova. However, there is also the possibility that we might be witnessing an even more terrifying event: the collapse of Betelgeuse into itself. This potential implosion could have profound consequences for the future of the universe. Betelgeuse, with a diameter 950 times larger than our Sun, is one of the most gigantic stars known. Despite its magnificence, its massive dimensions mean it has a limited lifespan and is essentially a ticking time bomb. Positioned approximately 650 light-years away, Betelgeuse captivates astronomers, who marvel at its brilliance and seek to uncover the secrets hidden within its fiery depths. Although only 13% of its radiant energy is visible to us, if we could perceive its full luminosity, it would surpass even Sirius, the brightest star in our night sky. Picture a star with a radius 764 times that of our Sun, stretching beyond the asteroid belt and nearly reaching Jupiter. In this vast domain, Earth, Mars, Mercury, and Venus would be enveloped by Betelgeuse's cosmic charm. Every millennium, Betelgeuse sheds a solar mass, casting off its celestial remnants in a spectacular display of stellar performance. A nebula 250 times larger than the star itself envelopes Betelgeuse, shrouding it in an ethereal mist that mesmerizes our gaze. This nebula extends 30 astronomical units, inviting us into a cosmic dance of wonder and beckoning us to uncover its mysteries. As the universe continues to evolve, Betelgeuse's impending supernova stands as a beacon of both scientific curiosity and cosmic drama. This massive star, with its unpredictable behavior, provides a unique opportunity for researchers to study stellar evolution in real time. The supernova event is anticipated to be a pivotal moment in the life cycle of Betelgeuse, potentially offering insights into the final stages of massive star evolution and the processes that drive such cataclysmic occurrences. The core collapse of a red supergiant like Betelgeuse can give rise to a variety of intriguing phenomena. When the star exhausts its nuclear fuel, the core contracts under gravity, leading to an intense buildup of pressure and temperature. This process can trigger a supernova explosion, ejecting the outer layers of the star into space and leaving behind a dense remnant. Depending on the mass of the remaining core, this remnant could become a neutron star or, if massive enough, collapse further to form a black hole. As Betelgeuse's supernova will not only be a spectacle for astronomers but also a vital event for understanding the dynamics of such explosions, supernovae are crucial to the formation of elements heavier than iron, which are scattered into space and contribute to the cosmic material that forms new stars, planets, and even life. The remnants of Betelgeuse's explosion will enrich the interstellar medium with these elements, continuing the cycle of stellar birth and death that shapes the universe. In addition to its impact on cosmic chemistry, Betelgeuse's supernova will provide a natural laboratory for examining the effects of such explosions on their surroundings. The shock waves from the supernova will interact with the surrounding interstellar medium, creating a pulsar wind nebula or a supernova remnant, depending on the explosion's characteristics. These interactions can trigger the formation of new stars and planetary systems within the nebula, showcasing the intricate relationship between stellar death and rebirth. Observing Betelgeuse's evolution in the lead-up to its supernova will offer valuable data on the final stages of a star's life. Researchers will monitor changes in the star's luminosity, spectral lines, and other characteristics to better understand the processes that occur just before an explosion. Such observations are crucial for refining models of stellar evolution and supernova mechanisms. The data collected could also help explain variations in supernovae observed in other regions of the universe. The impact of Betelgeuse's supernova on Earth will be minimal, given the star's distance from our planet. However, the event will likely have scientific and cultural significance for astronomers. It represents a rare opportunity to witness a supernova in a relatively nearby star system, providing a clearer view of the explosion's dynamics and aftermath. For the public, it will be a spectacular celestial occurrence, sparking interest in astronomy and space science. Cultural responses to astronomical events have historically ranged from awe to myth-making. As Betelgeuse approaches its conclusion, its eventual supernova will likely inspire a new wave of cultural and artistic expressions, from literature to visual arts. The dramatic imagery of a dying star and its explosive finale will capture the imagination of people around the globe, continuing a tradition of celestial events shaping human creativity and thought. In terms of technological advancements, the observation of Betelgeuse's supernova will push the boundaries of current astronomical instruments and techniques. Astronomers will likely deploy advanced telescopes and space observatories to monitor the event, capturing detailed images and spectra of the explosion. The data gathered will enhance our understanding of stellar processes and could lead to improvements in observational technologies and methodologies. The supernova of Betelgeuse will also serve as a case study for comparing the behaviors of different types of supernovae. By examining the characteristics of Betelgeuse's explosion and comparing them with other supernovae, scientists can gain insights into the factors that influence the explosion's outcome. This comparative analysis will help refine theoretical models and improve predictions of supernova properties, ultimately enhancing our understanding of the life cycle of massive stars. Furthermore, Betelgeuse's eventual explosion will likely become a reference point for future studies of stellar death and supernova phenomena. As one of the most anticipated supernovae, its observation will provide a benchmark for future research and help guide investigations into the end stages of stellar evolution. The data collected from this event will be invaluable for future generations of astronomers and astrophysicists. The study of Betelgeuse and its impending supernova highlights the interconnectedness of the cosmos. The life cycle of stars, including their explosive deaths, plays a crucial role in shaping the universe. By understanding these processes, we gain insights into the formation and evolution of galaxies, the distribution of elements, and the potential for life elsewhere in the cosmos. In summary, Betelgeuse's supernova promises to be a landmark event in both observational astronomy and astrophysical research. Its impending explosion offers a unique opportunity to study the final stages of a massive star's life and the subsequent impacts on the surrounding space. As astronomers prepare for this extraordinary occurrence, the anticipation underscores the dynamic and ever-evolving nature of the universe. The scientific and cultural significance of Betelgeuse's supernova will resonate far beyond the event itself, continuing to inspire and inform our understanding of the cosmos for years to come. As we delve into the heart of Betelgeuse's creation, we find that the alchemy of hydrogen fusion ignites and produces helium, setting off a cosmic explosion. Over time, the star's hydrogen fuel dwindles, leading to a celestial metamorphosis where helium intertwines with carbon, unleashing a brilliance that cascades through the cosmos. As neon merges with iron, an astonishing transformation occurs. The star's gravity, unleashed by the absence of energy release, triggers an imminent collapse, propelling Betelgeuse towards a fate that is both awe-inspiring and cataclysmic. In the realm of cosmic phenomena, supernovae reign supreme, and Betelgeuse will be no exception. With the energy equivalent to 10 billion suns, this immense astronomical entity will release a force that resonates throughout the universe, leaving us in awe of its unimaginable power. Over time, stars experience a captivating evolution, shifting from the bright blues of youth to the intense reds of maturity. In the 2nd century BC, Chinese astronomers noted Betelgeuse's distinctive yellow hue, which distinguished it within the celestial panorama. As the centuries progressed, Roman astronomer Timmo recorded Betelgeuse as exhibiting an orange or ruddy color. This feature continues to captivate us today. The consistent coloration noted by various civilizations, including medieval observers in the Middle East, adds to the allure surrounding Betelgeuse. In 2019, Betelgeuse astonished scientists by unexpectedly dimming. Initially, it was believed that a significant cloud of dust ejected from the star's surface obscured our view. However, the source of this cloud remains uncertain. Some researchers speculate that a large object, such as a planet, may have disrupted the star's surface or even been consumed by it. Recently, Betelgeuse has become nearly 50% brighter than its typical luminosity, an unforeseen event since stars generally become dimmer as they age. Scientists are unsure of the reason for this sudden brightness increase, but they recognize that star luminosity can vary for many reasons. For instance, certain stars exhibit cycles of brightness and dimness, like the star Mira, renowned for its regular brightness fluctuations. Deep within Betelgeuse, a seismic shift occurred. The eruption of scorching material propelled into space created a stunning dust cloud, obscuring a significant portion of Betelgeuse's brilliant light. This transformation changed it from a brilliant beacon to a more subdued presence in the night sky. Once among the 10 brightest stars, Betelgeuse now ranks below the 20th brightest. This dramatic alteration in luminosity has piqued the interest of scientists and stargazers globally. Some theories propose that a mix of ejected material and internal processes within the star might clarify the dimming, while others wonder if overlapping cycles could be responsible. Recent studies even suggest that Betelgeuse's supernova explosion may have already occurred. While conservative projections indicated that Betelgeuse's supernova event was hundreds of thousands of years away, recent findings suggest a different story. Researchers have proposed a model indicating that Betelgeuse may be in the final stages of carbon burning, making it a strong contender for the next anticipated supernova event within our Milky Way galaxy. Nevertheless, deciphering Betelgeuse is akin to assembling a puzzle of contradictory observations. Signs of material ejections and subsequent recovery hint at a mass ejection event, though smaller than that of our Sun. Supernovae are tangible phenomena, as evidenced by the one observed in a satellite galaxy of the Milky Way in 1987. Although estimates for Betelgeuse's explosion timing remain uncertain, there's no need to start making vacation plans around it just yet. The challenge lies in the difficulty of observing Betelgeuse. While scientists have studied it for centuries and noted its brightness variations, there is inadequate evidence to predict precisely when a supernova might occur. A supernova is a brilliant detonation that happens when a star meets its end, posing no threat to life on Earth. The luminosity of a supernova depends on the mass of the star that explodes. Betelgeuse's supernova would shine brightly, akin to the light of a half-moon, visible even in daylight. However, the radiance of a supernova could also present challenges for astronomers. The explosion's intensity would be so extreme that it could obscure the visibility of other stars and planets, complicating nighttime observations. One theory suggests that Betelgeuse may have absorbed a significant object, like another star, which could have accelerated its evolution and heightened the likelihood of a supernova. A recent study proposes that Betelgeuse's brightness cycles, especially the longest duration of 2,200 days, may represent the primary cycle for its pulsations. If validated, this theory could lead to substantial brightness changes for the star in the future. Despite the potential complications, the luminosity of a supernova would be a mixed blessing. It would be a breathtaking and exhilarating event to witness, yet could complicate observations for astronomers. Betelgeuse's potential to undergo a supernova offers a unique opportunity to capture its essence in striking detail. Unlike distant, twinkling points of light, Betelgeuse appears as a brilliant disk through telescopes, inviting us to observe its luminous variations and appreciate the intricate dance of its light. The supernova spectacle will not fade quickly. It will linger in our night sky for several years, gradually diminishing like a distant star. There may be moments of renewed brilliance before its light gently wanes. While the supernova poses no threat to us, it could confuse creatures that navigate by the moon's glow, as the additional cosmic illumination might disrupt their nocturnal routes. Astronomers will face new challenges in studying the universe, as a brilliant supernova will complicate observations during moonlit nights. Nevertheless, the allure of this celestial event will attract numerous telescopes and researchers, who will eagerly adjust their observations to capture the splendor of Betelgeuse's final act. The excitement among astronomers and stargazers is palpable as they anticipate the grand display of Betelgeuse's supernova. Earth is safe from danger, as Betelgeuse is situated at a comfortable distance. The explosion will not outshine the moon or the sun, but will cast an ethereal glow, illuminating our nights and making its presence felt even during the day for an entire year. Imagine the captivating sight of Betelgeuse's radiant remnants casting soft shadows upon our world. This cosmic performance will unfold over several years, initially dazzling us with its brilliance before gradually fading into the night sky. There may be instances of renewed luminosity before the star fades away, leaving us with cherished memories of its stellar magnificence. Researchers have discovered that Betelgeuse's brightness cycles resemble those observed in stars nearing the end of their lives, suggesting that Betelgeuse could soon go supernova. If it does, it would be the nearest supernova to Earth in centuries. The explosion would be visible to the naked eye and extraordinarily bright. However, this remains a hypothesis, and further investigation is necessary to ascertain when Betelgeuse will go supernova. Even if it does, it is unlikely to pose a hazard to Earth, as the star is approximately 550 light-years away. The first noticeable effect would be a burst of neutrinos, tiny particles that do not interact with matter and pose no risk. Following the neutrino burst, a very bright object would appear in the night sky, comparable to the brightness of a full moon. This luminosity would endure for several weeks before gradually fading away. The explosion would also disperse dust and gas into space, potentially obscuring some light from other stars and inducing minor short-term climate changes. While this celestial event won't pose direct danger, it may confuse creatures that rely on moonlight for navigation. The supernova's brightness could disrupt their nocturnal habits and confound their usual navigation methods. The increased illumination might also influence nighttime ecosystems, as the extra light could interfere with the natural cycles of various species. Betelgeuse's eventual supernova occupies a distinct place in the grand tapestry of cosmic events. Its potential to illuminate our night sky and captivate our imagination offers a chance for scientific discovery and public wonder. As astronomers eagerly await this cosmic spectacle, we are reminded of the profound beauty and dynamic nature of the universe. The impending supernova will serve as a celestial reminder of the universe's ever-changing nature, filling our skies with a brilliant, albeit temporary, display of cosmic magnificence.